Okay, welcome back. Lesson 26, Ratios, Rates, and Proportions. A critically important lesson to all my nursing students out there. So let's dive in. A ratio is the quotient of two quantities. So a ratio can be written in three different ways. You can say A to B, you can say A colon B, and you can say A over B, sort of written as a fraction there. All right, well, if it's the quotient of two quantities, I can physically write it as a quotient or a fraction, but I can also write it these other ways. And when you read the newspaper and you read the soccer game score was like 8-5, you usually see that colon notation, or if you do any gambling, like horse races or anything, the odds are 7-12, something like that. You've seen ratios written. What I'm getting at is in colon form and in fraction form. So let's practice. A percent can be thought of as a ratio since it is the quotient of a number and 100. So 53% really means 53 out of 100. Or you can write it as, the ratio of 53 to 100. But let's actually practice writing our ratios in a couple different ways. So first example, the score for the soccer game was 5-2. Okay, so I can say 5-2. I can say 5:2, or I can say 5/2. All right. So thus far, that shouldn't seem too hard. So again, just reminding us that the ratio of a number A to B is their quotient, and you have multi-ways of writing it. All right. Let's go to the next vocab word, a rate. A rate is a special kind of ratio. It is used to compare different kinds of quantities, meaning different units. Note to self, there's going to be different units on the numerator and the denominator. So 5 miles in 55 minutes, so 5 miles to 55 minutes, is equivalent to 1 mile in 11 minutes. Well, actually, it turns out when you get a ratio that has 1 in the denominator, that's called a unit rate. So I want to kind of add to our notes here, a unit rate. Now, this one I have 1 in the numerator, but so if I flip the fraction, it would be in the denominator. But a unit rate has 1 in the denominator. So let's just play a little bit here. If I drove 120 miles in 2 hours, what's my average rate of speed? So average rate of speed is total distance divided by total time. So 120 miles in 2 hours. Well, I can clean that up, reduce it, right? So that's 60 miles in 1 hour. So 60 miles per hour is my average rate of speed, but it turns out that's a unit rate because 1 is in the denominator. So if I said 120 miles in 2 hours, and if I said find the unit rate, you would say 60 miles per 1 hour. Always trying to get 1 in the denominator when you're looking for a unit rate. And again, I reiterate that here. So let's use our knowledge of unit rates to tackle this word problem. So a store charges $2.76 for a 12-ounce jar of pickles. What's the unit price? So unit price means so much money per 1 ounce. So we're looking for so much money per 1 ounce. So I'm going to have to divide the numerator by the denominator, right? So I'm going to have to take 12 into 276. Now, if you're at home and you want to use a calculator, that's okay. In this class, live, we don't use calculators, so 12 goes into 27 twice, but I would definitely practice without a calculator. 12 goes into 36 3 times. So we're looking at the unit price there being 23 cents per ounce. Now it says, so which is the better buy? This above situation or $4 for a 16-ounce jar of pickles? Well, let's try taking 16 ounces into $4. Well, 16 goes into 40, about twice, right? Draw the line and subtract. Let me scoot that answer down. And 16 goes into 80 5 times, so 25 cents. So the unit rate on this situation, or the unit price, you could say, is 25 cents per ounce. So a lot of times we go to Costco and we think the bigger is better. And typically Costco is, you're getting more bang for your buck. But it might be a trick. Like in this case, you're getting more bang for your buck here. 23 cents per ounce. This one, 25 cents per ounce. Note to self, this one's cheaper. It's the better buy per ounce. Getting more bang for your buck. All right. So long story short, when you see the better buy problem, it's a pretty standard problem, compare unit prices. All right. And you see my partial 23 cents per ounce versus 25 cents per ounce. This is better. Okay. Let's practice more on the next slide. Find the unit rate. So now we know unit rate means per one. So we're looking for per 1 gallon. And we know the recipe is basically to divide the denominator into the numerator. So let's test that out. 17 goes into 31 about once. 1 times 17 is 17. Draw the line and subtract. Okay, bring down the next guy. I could say line up the decimal. 17 into 144 goes about 8. And even if you need to go off on the side, I was going to say if you need to go off on the margin and be like 17 times 8 is 136. Draw the line and subtract. Bring down the last guy. And 17 into 85 goes 5 times. So we're arriving at 18.5. All right. And we see the answer, 18.5. Always make your units miles per gallon. Okay. Hope that helps. So again, with the general strategy, when you have a fraction like this and you're told to find a unit rate, just divide the bottom into the top, the denominator into the numerator. So take the denominator, just writing the recipe, into the numerator and divide that. All right, let's try the next slide. Now a new vocabulary word, a proportion. So a proportion is a statement that two ratios or rates are equal. So if I claim that A over B equals C over D, so just think about it like that. It's a claim. It's a claim that A over B equals C over D. Well, you can make that claim, but in order to be a true proportion, and I have a big note over here, to determine if a proportion is true, we must investigate the means and extremes. The product of the means must equal the product of the extremes. So note to self, product of means must equal product of the extremes in order for it to be true. So you test to see it. So let's dive into this example. So is 3 over 8 equal 12 over 32? Is that a true proportion? So it's a claim that two ratios are equal. Well, if we investigate, and you see the drawing here, if we investigate the means extremes, here's the product of the means, 3 times 32 makes 96. Here's the product of the extremes, 12 times 8 makes 96. 96 equals 96. We know it's a true proportion. So when the product of the means equals the product of the extremes, we know that you have a true proportion. Let's try this one over here on the side. I'm going to rewrite it. Is 5 over 12 equal to 30 over 72? And by the way, some of you might say, well, gee, 5 times 6 makes 30 and 12 times 6 makes 72. So yes, but we're looking at it in a different way because it's going to lead us into algebra here in a moment. So we want to investigate, does 5 times 72 equal, question mark, 12 times 30? So, well, let's see, 72 times 5, that's 360. And 12 times 30, gee, that's 362 as well. So yes, the product of the means does equal the product of the extremes, so it is a true proportion. All right. So safest thing I can tell you is if you're asked if two fractions are equal or two ratios are equal, if it's a true proportion, just cross multiply. Investigate the cross products. Oh, there's a good word. Cross products. Investigate the cross products. See if they're equal. Okay. Let's try the next one. We can always use this means extremes, or this cross products property, to help us solve for x. So now that we know that the means has to equal the extremes, we know that 28x then must equal to whatever 26 times 49 is. Now, I know this is a no calculator course, but so I'm going to go in faith that you know how to multiply 26 times 49. For time's sake, I'm just going to give you that information, let you try that on your own, but 26 times 49 should lead us to 1274. And then right here at the end, when you're solving for x, you want to isolate x, so you're going to have to divide by 28. And like I said, in a no calculator course, you would physically have to take 28 into 1274. If it's a calculator course, you can just key in 1274 divided by 28. And you get 91 halves, which is the same as 45.5. Encourage you to try to do that by hand and arrive at 45.5. Okay? The only way to know that 45.5 is correct is to throw it back in and investigate whether that's probably worth investigating. Let me hit pause. If I claim that the answer is 45.5, know that I can take 45.5 and check. Store it back in. And I'm just going to do a quickie check on the calculator just for time's sake. So 26, let's test it out. 26 divided by 45.5 is something. Okay, 0.5714, I'm just rounding. So let me say it like that. 26 divided by 45.5, that led us to 0.5714. And now test out, erase my writing there. Now test out, so we tested out 26 divided by 45.5 and got 0.57. Now test out this side of the playing field. What's 28 divided by 49? Okay, let's try it. 28 divided by 49. Well, gee, that's 0.5714 as well. So what I'm getting at is it checks out. So if we check it, the solution, we find out that 0.57 balances with 0.57, and voila. We know we did it right. Okay? So just reminding us to take 45.5 and throw it back in. So store 45.5 in for x to check. Okay, let's try this example. I thought this would be a lovely one here with the fractions. This one here. We're dealing with fractions, so means extremes. So 1/4 times x, 1/4 x equals, well, what's 2 times 3 and 2/3? Well, I'm not going to think about it mentally. I'm just going to write it out. Okay, and step it out bit by bit. So 1/4 times x is 1/4 x, and 3 and 2/3 times 2 is something that we're going to figure out, right? So now we have 1/4 x equals 3 and 2/3 is a mixed number. You're going to want to change that to improper. So that'll be 11/3. And then, I was just realizing I should probably scoot down. Let me see if it'll let me scoot. Yeah, I want to scoot down that problem. When you arrive here, you have 1/4 x equals 2 times 11/3 is 22/3. And I say don't fear the fraction. So to get x by itself, you would have to divide both sides by 1/4. Or you could even say dividing by 1/4 means multiply by 4. So you could multiply both sides by the reciprocal of a fourth, which is 4/1. So in the end, x equals 88/3. So final answer to that one, 88/3. So never fear the fractions. We know how to deal with fractions. That shouldn't be a problem. I will say, I know a lot of people, even though it's not a calculator course, a lot of people ask me, can I just practice doing some of these fractions on my calculator? Yes, I would say after you convince yourself you can do it by hand. But what I mean is when I see an original, when I see 3 2/3, I know that means 11/3. So what I'm getting at is I can take 11/3 times 2 on my calculator, and then I can basically divide it by 1/4 on my calculator. And it'll spit out a decimal, but if I hit math frac, it'll spin it back into fraction form. See, 88/3. So, you could definitely use the calculator as a crutch, but make sure you know how to do it by hand. Okay, and last but not least, let's use means extremes to solve this one. Well, gee, x times 9 is 9x, and 7 times 4 is 28. So 9x has to be 28. Therefore, we divide both sides by 9. Therefore, we have 28/9. And by the way, you can leave your fraction like that. You don't have to give me a mixed number. You don't have to give me a decimal. You can leave it as an improper fraction. Okay, hope that helps. And let's see if we have anything on the next slide. Nope. That was it for our guided notes for today. Good luck out there.